Alright, the second part of Chapter 6 was about combining random variables. Depending on which class you're in, I either did an example with college credits or I did an example about going to a restaurant. So back in Chapter 2, we studied the effects of linear transformations. So if we added or subtracted something, that changed the measure of center location, but it did not change the shape or measures of spread. When we multiplied or divided by something, it changed the measure of center and location. It changed the measure of spread by the absolute value of b. Now this doesn't include the variance. The variance gets changed by b squared. And it does not change the shape of the distribution. So we talked about transforming variables. This one example right here is about Pete's Jeep Tours. So he has to have at least 2 passengers. So this is the number of passengers that he has. A vehicle can hold up to 6. So this is the probability that he gets those passengers per vehicle. There's this histogram of that. It looks pretty normal. You can find the mean and the standard deviation. If he charges $150 per passenger, then all I need to do is take 150 times the number of passengers. So those would be my new values there. My histogram looks the same, so the shape didn't change. The mean changed by multiplying it by 150. The standard deviation also changed by multiplying that number by 150. So the shortcut here is if you're asked to transform the random variable, it's similar to when you're transforming like a single variable. If it's multiplication, it's going to impact the measures of center and the measures of spread. Again, it doesn't impact the shape. And again, likewise, as I said before, it'll multiply or divide the measures of spread by that absolute value of b. And we're just talking about range, IQR, and standard deviation. If you were talking about variance, you'd have to square b. Alright, let's say if we go back to his costs here. So there's the histogram of costs. And now he also has to, for every trip he takes, he has to pay $100. So regardless of how many passengers. So I can subtract 100 from each of those values. My histogram looks the same, so my shape looks the same. If you notice here, if I find the new mean in this, the mean is going to decrease by 100. So just like each value decreased by 100, but the standard deviation does not change. So when I add or subtract, just like before, the mean changes, the standard deviation doesn't, and the shape doesn't. Alright, so when you're adding or subtracting, it changes the measure of center location, and it's not going to change the measure of spread. It's not going to change the shape. So that's a shortcut. So this is just kind of summarizing everything here. If you were actually going to do both at the same time, so if you were going to add and multiply, then the addition and the multiplication will affect the mean. The shape is not going to be affected. And then the standard deviation is only going to be affected by the multiplication. Alright, now besides looking at just transforming, we can also look at combining random variables. So now we have 2 things. We've got Pete's Jeep Tours, and then we're going to add Aaron's adventures. So I don't know, it's his sister and she wants to have her own little thing. So there's Pete, here's Aaron. So she also has her own little cars and stuff like that. And they have their own little, each has their own mean and own standard deviation. Alright, so if we combine random variables, what we're doing here is we're combining all the possible outcomes. So when we combine those random variables, when you want to just combine the means, you can just add the 2 means together. It's pretty straightforward. So just the total between the 2 of them is just, the expected total is just the means added together. Alright, as far as the spread, they go through a little bit here about exploring the distribution, which we did talk about here in class. I'm not going to spend too much time on it now, but we're making an assumption that the 2 variables are independent of each other. By making that assumption of independence, that means we can multiply the probabilities. So we've got these 2 tours here. These are the possible outcomes for Pete. These are the possible outcomes for Aaron. These are their respective probabilities. They add together the x and y, they multiply the probabilities, we create this histogram. So the mean of all that was just that. To find the variance, what they do is they go through the formula. There's the variance. They take the square root and get the standard deviation. So this was the variance of Pete. This is the variance of Aaron. So if you look at that right there, the variance, actually, this variance of the sum is just going to be the sum of the two individual variables. So the point here, or the shortcut, is that variances will add, but standard deviations will not add. So you just need to remember that. So if you're asked to combine random variables, just remember that the variances are going to add together. Alright, when we talk about differences, so if we were taking the differences in the two variables, the mean of the differences is just the differences in the mean. And remember, your order of subtraction is going to be important. But if I'm talking about the variance of the differences, you're still going to add the variances. So you're not subtracting the variances, you're not subtracting the standard deviations, you're adding the variances. So we need to remember that. Alright, so those were discrete ones. We can also combine normal random variables. So Mr. Starnes likes between 8.5 and 9 grams of sugar in his hot tea. Suppose the amount of sugar in a randomly selected packet follows a normal distribution with a mean 2.17 and a standard deviation of 0.08. If Mr. Starnes selects 4 packets at random, what's the probability his tea will taste right? Alright, so X is the amount of sugar. So they're defining a new random variable as T equals, so 1, 2, 3, and 4. There's 4. He's using 4 packets. And his tea is only going to taste right if it's between those two values. So the mean of that is just that plus that plus that. And again, in this case, you can do 4 times that because there's 4. They're all the same mean. They're all coming from the same distribution, so we're assuming that they're all the same. For the variance, I'm going to add all the individual variances. So that's the standard deviation. I'm going to square it to get the variances. Again, you could just do 1 and multiply it times 4 since they're all the same value. And we get that answer, we take the square root of it to get the standard deviation. So then to find the probability, they're going to go back and use the normal curve and standardize it. I would just use normal CDF, and I would have 8.5 to 9, comma the mean that you just found, comma the standard deviation, and I would get my answer that way. So there's about an 85% chance, and again, you'll probably be slightly off there just because you're going to use the calculator. Alright, I'm going to leave this up for a second if you want to pause the video to look at that. And again, it's just important, even if you're adding or subtracting, you always add the variances. With the means, you either add or subtract based on what you're doing.